Hello and welcome. This is Cryptosh Chain with a new episode of Simple Cryptocurrency Reviews, and this is a special review episode because instead of focusing on only one coin like I normally do in my reviews, I'm going to be talking about two different coins on a specific protocol. This is a new protocol which I want to focus on. I want to explain how it actually works, explain it in a simple way like I normally do on my channel. And there's actually a person called Connor Higgins who wrote an article on Medium who explained it in a really simple way, so I can actually use this as a reference to help you, the viewer, understand how this actually works, because this is important, especially if you're non-technical. Right, so let's get right in. So we're going to be talking about Mimblewimble, right? Mimblewimble is a protocol. Now, what is it? So Mimblewimble is a ridiculously named technology that stops blockchain from blabbing personal information, and it's named after a Harry Potter spell that stops people from spilling secrets. Now, Satoshi Nakamoto's Bitcoin paper had a section titled Privacy, in which Nakamoto is very realistic about Bitcoin's privacy limitations. These limitations have gotten worse as adversaries have gotten better at using the data Bitcoin spills to dox and de-anonymize Bitcoin users. This surprised some people who thought Bitcoin was private because it doesn't disclose names. Let's look at what data it does disclose and why. So this is actually really well explained here because it says Bitcoin blabs 3 secrets to fulfill 2 requirements. So this actually explains us why the name Mimblewimble came into effect. Right, so let's see. So what are the 3 secrets that Bitcoin blabs about every transaction, right? So it's the sender's address that we get, the amount of coins that are sent, and the receiver's address, right? So this is the information that we see when we check the blockchain explorer, or even when we check a transaction, right? Any Bitcoin transaction contains this information. So these are the 3 secrets that have been spilled by Bitcoin, right? So Bitcoin doesn't reveal these secrets because it hates privacy. It reveals them because any money system, gold, cash, barter, has to fulfill 2 requirements, right? It has to verify the amount received. So for example, if I send you 5 euros, okay, 5 euros should leave my wallet and 5 euros should reach your wallet, right? So in this case, this guy is actually explaining that it should leave your hand, it should leave my hand, and it should go to your hand, right? That's how it should be. So I should be left with 0, you should have 5, right? So this is a pretty good explanation, right? This is like the basic explanation of what you need to understand of how a transaction actually works. Now, the second thing is that you cannot initiate a wire transfer from your bank account, but rather only from your own. We have to verify that the transaction is sent by the holder of the debit card and PIN, or the online banking password, or the private key in the case of cryptocurrencies, right? So this is what we use. Now, Bitcoin fulfills the 2 requirements by spilling the 3 secrets above. Now, so let's go down and try to understand Mimblewimble. So Mimblewimble fulfills the 2 requirements while spilling 0 of the 3 secrets, right? So this is where the privacy aspect comes into place with Mimblewimble, and this is why it's so important to basically hide any transactional information that you have produced, right? So basically, if I want to send 5 euros to another person, 5 euros worth of Bitcoin using the Mimblewimble protocol, nobody can actually find out that I've sent 5 euros, right? They cannot see the public address, they cannot see any details about the transaction or the amount. Everything is hidden. So this guy is actually explaining how, right? So multiplying is easy, but factorizing is hard. Now a lot of people are scared of maths, right? So he's specifying that, and then he's giving you an example here, right? If you multiply 23 by 19, what do you get, right? So obviously if it gives you some time, you will be able to calculate or simply get the calculator out to get your answers, right? These are the answers here. And then he's making a little change. So he's actually saying, what if you change it the other way around? What if I give you the answer, but you don't know what the calculation is, right? What if it's question mark? So this is about privacy. This is about hiding the information, right? The end result is the same, but we don't know what the actual calculation or the formula is, right? Well, sorry, we know the formula, we don't know the calculation. We don't know what numbers are behind it, right? We need to basically get that in, right? Think about what could give us this result, 923, right? So yes, let's go down and talk a little bit more about this, right? So he's breaking it down here, and he's exploiting the properties of multiplication to hide the information and verify ownership, right? So he's given a bigger example. So like, what are the missing numbers here, right? 11 by 57 by question marks by 17 by question marks gives you 20,348,031, right? So obviously you can do that, right? There are calculations that you can do to find out what could give you this amount, right? Obviously you can't easily tell it because you need to use the formula, but it can be checked, right? So let's see. So then he's given a bit more examples. Of course, for example, you get the calculation, but you don't know the answer. So of course, that's easy to get if you do it, right? If you do this calculation, you'll get your answer. So you'll know what this multiplication is equals to. Now, this is quite interesting because he's saying here, if I had lied to you, you would easily find out because my factors wouldn't give you the big number on the right, right? So this is it. So this is how you can check that the transaction is valid. This is how it works in the back end. So let's go down and talk about hiding the transaction amounts. So this is how it would actually work, right? So we've got the amount multiplied by question mark equals this, right? So in Mimblewimble, the sender and the receiver each come up with a number like this. You've got the amount multiplied by the big number plus the key multiplied by the big number, right? And this is called the Pedersen commitment. Now he doesn't know why, and the important thing to realize is that it contains an amount part but hides the amount by multiplying it by a big number and the private key part. Now this Pedersen commitment is actually part of a cryptography protocol, right? Cryptography information. So if you actually search on Wikipedia, you can find the definition in the cryptography session for the Pedersen commitment. So it's quite deep stuff, right? You need to go really deep into cryptography to break this down and to understand what it is. So note that the sender and receiver both participate in creating the transaction, right? But this is pretty different than Bitcoin because this gets around the need to blab the recipient's address, right? So this is the secret right here, right? We don't know what the address is. So this is cool, right? And makes it necessary for some other way of the sender to reach the recipient. Now, Beam includes a secure BBS system to separate from the Beam blockchain, separate from the Beam blockchain, and to allow the sender and the recipient to exchange the Pedersen commitments. Let's go down. Okay, so here he's given another example. You can multiply all these numbers, right? And then you get your answer. But let's go down. So here's the example again. Okay, so the amount sent multiplied by the big number, the key multiplied by the big number plus the amount received. Okay, this is the output multiplied by the big number and key 2, right? This is private key. This is the other wallet. This is the receiver's wallet multiplied by the big number. So if we go down, here's an example with an actual value. So we've got 5 euros leaving the wallet, right? Verified with the key. 5 euros entering the new wallet, the receiver, verified with the key. And this is the other calculation that we've got. For example, minus 5 plus 5 multiplied by big number plus key 1 plus key 2 multiplied by the big number. So these should actually match. So 5 minus 5 is 0 multiplied by the big number, and it's still 0. We're left with 0 by big number, key 1 plus key 2 by big number, or just key 1 plus key 2 by big number, right? So the amount part vanished, yet at every step the amount were always blinded by multiplying them by big unknowns. We verified they came to 0 without disclosing what they actually were. The reason the amount part vanished is because money in and money out were equal. If they were not equal, then they would not have come to 0. So we'd be left with something more than just the key part. So this is how it actually hides the amount, and we never actually see it in the Explorer or in the transaction information, because this is hidden by cryptography, and cryptography knows, right? When it validates, that's when it knows that the amount is correct. So that's how this would actually work. So he's explaining it here again. Let's go down further. So there are two reasons that why the transaction kernel is divisible by the private keys, because the amount part came to 0 and because the key part was formed by multiplying a bunch of numbers, including our private keys of 83 and 23. These are the two requirements we had for any money system. So if the amount part came to 0, that means that the amount in minus amounts out equals to 0. In other words, that amounts in and amount out are equal. In short, no money vanished and none was created. We have accomplished that first by hiding them through multiplying them by a big unknown and then smooshing them both together, letting them cancel to 0 while under the cloak of the big blinding number. And the second requirement was to prove that the transaction was generated by the holder of the private key and that the sender proves that by showing that his private key divides into the transaction kernel, which means he was a factor that constructed the kernel. So that explains it. And of course, Mimblewimble arguably achieves Bitcoin's goals better than Bitcoin itself, right? Because this is a privacy, right? So if privacy was a goal, then it does better than Bitcoin. So unlike some privacy coins which add obfuscation on top of Bitcoin, Mimblewimble achieves it by cutting. Right, we found it exciting enough that we started building a full implementation earlier this year and expect Beam will launch before the end of 2018, making Mimblewimble a reality. So again, this article is a bit older, but I just wanted to get to it because it explains it in a clear way for non-technical people with any basic maths knowledge, basically, right? So this is pretty cool. Now we understand the privacy aspect of it. We understand why it actually hides the amounts, right? Because we don't want the amounts to be shown to the public, right? This is the whole purpose of the privacy, and it shows you that it's working, right? So it's really good. So yeah, this guy obviously, well, probably works for Beam because we can see here that he's expecting Beam to launch. That's what you're saying, and he's giving more information on Beam, but he's not mentioning anything about Grin. So let's talk about Grin actually as well, and to talk about the difference between them. So rather than break through each one, right, what I'm going to do is I'm going to talk about the difference. So let's go down here, right? So Grin versus Beam. So one of the primary differences between Beam and Grin. So now these two, right, these two are coins, Grin and Beam, just to make that clear. And these two coins are the only coins created on the Mimblewimble protocol, which we've just explained earlier. Both of these coins are proof of work, right? So just like Bitcoin, they can be mined. Now, to talk about the differences. So Beam's governance and development model is a more company-like structure design, similar to Zcash, while Grin draws inspiration more from the Monero model of an open source community members independently working on the project through donations. Overall, we can separate the main variations between Grin and Beam into several categories: monetary policy, governance community, mining, technical nuances, and direction. So we've got the monetary policy. So with Beam, just to keep it simple, I'm not going to read through the whole thing, but I'm going to cover some parts. So there will be a maximum supply, which is 263 million Beam. That's how many you could have, right? So that's going to be the maximum. Once they all enter into circulation, that's it. That's the maximum, right? So then they're saying that the block reward, right? So the way they're produced when you're mining is quite similar to Bitcoin. So because this is the first year, right? It was launched in January 2019. The block reward is at its highest right now, and it's 80 beams per block. So this is quite a lot, right? And it will halve approximately every 4 years until the 133rd year when emission stops. So yes, every 4 years we're going to get a halving. So we're going to get 40 beam coins, then 20, and so on. So yeah, 80 beam coins is not too bad if you think about it. Obviously, if you have a good rig, again, this is not financial advice, this is not mining advice. You know better than me, especially if you're mining, but it's just to show you that, you know, it's there, and it does give you that opportunity, right, if you're a miner. Now, the important thing is that Beam issues rewards on a per block basis to the Beam treasury that are paid out on a monthly basis to the Beam Foundation, including investors. Now, the reward that goes to the treasury is 20 coins per block for the first year and decreases to 10 coins per block throughout the next 4 years. So in reality, it looks like you're left with 60 Beam coins per block because 20 go to the foundation, right? They need to make money somehow, right? So you gotta understand it. Right, so Grin, let's talk about that a little bit. So this is coin is designed as an anonymous currency with an uncapped supply. So this is the part that I really don't like about Grin, is that okay, since day one it had, it started getting mined, coins started getting produced, but it's inflationary, right? We're going to get unlimited supply, an unlimited supply. So we've seen this with many coins that have huge supply, right? We've seen what happens, especially to the price in terms of being an investor and even a miner, right? So it may be worth it at the beginning, in my opinion. It may be worth mining it, but in the long run, who knows, right? Because the price is going to drop a lot when more are being mined, more are being produced, more will be in circulation. Obviously, there will be a lot of them, and if there isn't enough demand to keep the price high, then you've seen what happened, especially in this bear market, right? Who knows what's going to happen in a bull market, but in this bear market, this is not good, right? This is horrible, in my opinion. I'm not saying the tech is bad. So the tech, I'm going to talk about the tech in a bit as well. But the fact that it's uncapped, unlimited supply, I don't think that was a good idea when they designed this. This is my personal opinion, right? So yeah, let me know what you think, by the way, in the comment below. What is your opinion on the unlimited supply? What do you think of it? I mean, do you see that as something positive? It's just, it's the way it is, Okay, so rather than a store of value, Grin is predicted more on its use as a fungible and private currency for transactions. So new Grin coin is minted every second, equating to 60 per each 1 minute block, and the overall dilution of the inflation decreases over the years, eventually approaching zero, although never actually reaching zero. Okay, right, so I see that. So the dilution of the inflation decreases over the years, right? Okay, right. So it's probably going to become more difficult, right? Because we're getting 60 per the 1 minute block, and the overall dilution of the inflation decreases over the years. So if we're understanding this correctly, it's going to drop as well. So if it keeps dropping but never reaching zero, then that means we're not going to be producing as many into circulation as we may think. Well, it's still unlimited, right? So at some point it's going to be a lot, but yes, maybe a developer could have a look at the code in GitHub and try to understand, for example, where are we going to be in, I don't know, say 10 years maybe? How many could we potentially see in circulation, right? So yeah, that's something to look at and to try to understand, because maybe I was wrong about it, right? So it's something to consider. So the implications of Grin's monetary policy are intriguing and is a unique perspective in the broader cryptocurrency sector. Grin does not have a treasury, founder's reward, or company behind it, and instead relies on donations and voluntary participation through an open source structure, just like Bitcoin, right? So this is where the similarity is, and this is where all the hype is, right? Grin is considered kind of like the next Bitcoin with the privacy aspect to it. So yeah, then they're talking about the governance and the community. So Beam's governance and early VC funding resemble a startup approach, where full-time developers and contributors are hired in a traditional company setting. The Beam Foundation currently oversees the project, a non-profit to be set up in Switzerland that will guide the development of the network. The other thing I wanted to talk about, let me go down a bit. Okay, so here they're talking about Beam mining. I'm not going to go into that detail. You can have a read through this. I'm going to post a link to this article. Now here we go. So the languages, right? So Beam is written in C++, while Grin is written in Rust. Now Rust is a newer language. This was designed around 2010. It can inherit the libraries, right? From a developer point of view, it can inherit the libraries from C++, which is a really old language, but very good as well. A lot of games are actually built using C++, right? So all these games you see, all these cool graphical games, they use C++, right? It's just the way memory is handled and everything, so you can actually set it to dump, right? If you're not a developer, you probably don't understand this, but basically it's easier to use C++ for a game. It's just because of the way you can manipulate the language to make it work well for you and prevent the game from causing problems, from crashing and things like that, to make it run smoothly. So yeah, Rust is a new language, right? It's supposed to be more secure, but again, it can inherit the libraries from C++. So we can say that it's kind of an addition to C++, right? So this is a newer technology. Grin emphasizes a minimal implementation of Mimblewimble, Grin currently only has a CLI wallet, and Beam has a GUI and a CLI wallet. So this is the other thing I wanted to talk about. Grin don't actually have a Windows wallet. So a lot of you that have Windows PCs, you won't actually be able to store Grin on your Windows PC, but there is a way around it, which is to create a virtual machine. Once you create a virtual machine, you will be able to access Ubuntu, which is an operating system based on Linux, to be able to install this wallet in order to store green coins, right? With Beam, it is available on Windows, and there's also a mining feature within the wallet, right? So it's a graphical user interface, and you've got the mining feature within it, which is quite cool. It makes it easier for a new starter to start mining Beam, basically. So they're really pushing for Beam adoption, whereas with Grin, it's making it more difficult right now for your regular person. Mostly aimed at developers from the way I see it at the moment, but it's going to be aimed at everyone, right? It's going to be aimed at everyone. Eventually, they are actually working on a Windows wallet as well, from what I've read. Privacy is the default and non-optional in Grin. Beam enables opt-in auditability. Okay, right, I see. So basically, Grin is 100% private. Beam has the option to make it auditable, right? So this is a bit of a question mark here. Grin takes a more experimental approach in technical developments than Beam, right? So yeah, they're experimenting. Things could go wrong. Keep that in mind, but they could go well too. Beam enables non-interactive offline transactions via secure BBS system, and Grin uses the plain text such as email. So that's how you do the transactions. Beam Core is the technical avenue of the Beam project and has numerous developments in the pipeline over the coming years, including Agile Atom, an API documentation and ecosystem, Bright Boston, which includes atomic swaps with Bitcoin, hardware wallet integration, Android mobile wallet, Lightning Network. Wow, that's pretty cool. Integration with BTC Pay Server, mining algorithm hard fork, iOS mobile wallet, web wallet, multi-sig. So it looks like they're really pushing, right, for Beam to do well. I mean, it's a company behind it, right? So they're gonna try and really push for that, because they're gonna get the money, right? They've got the money, they've got the funds, so yeah. Grin also has numerous innovations on the horizon, including Green Swap, which is also an atomic swap functionality, confidential assets, Schnorr signatures, I'm not sure what that is, possible ZKP integration, BLS signatures, again, I'm not sure what these are, multi-sig support, time-locked transactions, and Lightning Network. This is cool. Hidden nodes, onion routing, blockchain pruning, dandelion protocol optimization. So Grin is continually undergoing suggested upgrades and improvements in a more rough consensus style, which can be found in its community forum and GitHub repo. Notably, both Grin and Beam already employ the Dandelion as a network layer privacy enhancement, which is pegged for inclusion into Bitcoin this year as well. So yes, pretty cool. Let's see how that progresses and if it goes to Bitcoin. I think it will, but we'll keep an eye on that. Now, one of the challenges that both Grin and Beam will face is adequately reaching a level of network decentralization while incentivizing miners to contribute more hash power to the network, securing the chains. Both projects are mitigating ASIC functionality in the early stages, and bootstrapping a proof-of-work based cryptocurrency is an arduous task. Gathering support of GPU miners in the first couple of years is crucial to decentralization before the ASIC market matures. Okay, so that explains why we've seen some news recently from Sapphire, right? Who are actually developing, they're a company which develop graphic cards, and they're developing graphic cards specifically for mining Grin, right? So they're focusing on that. Basically, you're going to get more Grin if you use those graphic cards than if you use some traditional ones. So they're specifically built for that. Launches of new protocols also come with inherent criticism of what constitutes as a fair launch. So yeah, we don't know that. So yeah, the conclusion, this guy is giving his conclusion here. By the way, this was posted by Brian Curran, so thank you very much for this article. It's very good because we can actually break it down on this video and we can discuss it. So Grin and Beam are the first two full Mimblewimble implementations and bring with them some substantial advantages in privacy and efficiency. So this is pretty cool. Yeah, I mean, we're gonna have to keep an eye out and see the progress, but this is pretty much it. I hope you understood it. And before we go, I just want to talk about GitHub a little bit. So if we look at GitHub here, this is the green section of GitHub. We can see they've got 1,864 commits, 111 contributors, so quite a lot of people contributing. There are only 4 branches, there were 8 releases. And if we go to the core section, we can actually see here, then we go to the source section, we can see that these files which end in .ors stand for Rust. These are Rust files, and it even tells you here convert to Rust 2018 edition. So all these files that are part of the solution, we can see all of those here. We can see the brands, the branch which is master, all the pull requests, everything is visible, right, as we can see with other projects. And if we go to Beam, we can see 11 contributors, so much less, only 10% of Grin's contributions, and a lot more commits, right? So these people are working a lot more commits. Obviously they're being paid, right? So in the other one with Grin, you know, they're not being paid. I mean, they are being paid, but it's based on donations from the community, right? From the crypto community, from companies, etc., etc. There are a number of companies that contributed, that donated to help the developers build the network. With this one, again, it's the company paying them. That's why we've got so many commits. But if we go to core, we can see the CPP file extension, which stands for C++, right? So this is how you can tell which language it is if you go to that. So finally, before we end this video, I just want to talk about the price a little bit. Normally I don't do that. I mean, I do that when I talk about specific projects. So I just wanted to say, yes, Beam is currently standing at 154 at the moment. It's down 12.8%. We can see the total supply at the moment that's been mined 3.2 million. And we can see there was a bit of a pump and dump. So it actually started around, if we go back to 18th of January, 64 cents, right? So that's quite low. And look at this, it went to like $3. So whoever caught this was really lucky on January 28th. So only 10 days later, that's like a 6x increase. So that's pretty good. Then crashing, of course, as more are coming into circulation. It held $2 for quite some time, but yeah, it's down now. It's down. Anyway, still, I mean, if we think about it, it's still quite a lot bigger, more than 2x bigger than when it was on the 18th of January, right? So it's doing pretty well. But as the supply increases, if the bear market continues, we could see a drop lower, in my opinion. So personally, I'm staying away from this. I'm not touching this. I'm just going to watch it. But if you're mining, that's great, right? You're mining, so you're producing and then you're just selling, or maybe you're keeping it until hopefully the price increases and then you're selling. But I'm guessing a lot of miners normally sell straight away because they need to pay for electricity and costs, etc., etc., and they need to make a profit, a living, right? And let's talk about Grin as well a little bit. So the price is 598, again, huge drop. We've got 1.3 million coins currently mined. And if we look at the price history, this is when it was listed on CoinMarketCap. It actually went as high as around 15 bucks, I believe it was, on Qcoin. It says here 1460. So yeah, about 15 bucks on Qcoin when they launched. They're on a number of exchanges at the moment, including, like I said, Qcoin, Bbox, and Hotbit. So when they were on Hotbit, I remember seeing them for like $4. I didn't actually enter. But yeah, I mean, I was tempted, but I didn't do it, and I kind of regretted it because a few days later they got listed on Qcoin and the price spiked to 15 bucks. So that would have been more than 4x there, right? So yeah, it is what it is, you know. It is what it is, and sometimes you can miss the boat. Yeah, again, I'm gonna stay away from this just because, you know, it's inflationary. We know that more are gonna come into circulation. It's a bear market. The price is down quite a lot, so a lot of these miners are probably dumping it now. So yeah, let's keep an eye out and see how things go. Okay, well, that was pretty much it from this video. This was quite a long video. I hope you enjoyed it. Again, if you're new to my channel, I would appreciate if you could please subscribe. It would really help. Do leave a comment below this video if you have any sort of questions or if you have any sort of doubts. I'll try and get an answer for you. And please like the video too if you enjoyed it. I'll see you in my next video. Thank you very much for watching. Have a lovely day. Goodbye.